Okay, welcome to our first Tech Talk of July. My name is Wayne Welk, and I'm just going to kick this off real quick and introduce our guest speaker. We're going to go a little longer today than the normal Tech Talk format. Typically, we're 30 minutes on a Tech Talk. Today, we're going to go probably a good hour, maybe a little bit more. So hopefully you guys can hang in there. Today will be a presentation on industrial cybersecurity, and our guest presenter is Luis Ramos with Rockwell Automation. And Luis, you can show your picture there on the next slide. Oh, no, actually, there's Luis, and we'll turn it over to him in just a moment. And our topic will be kind of a very fair, shall we say, an unbiased presentation on cybersecurity and just some of the risks and um, just a good discussion around it. And we will definitely encourage questions during the presentation. You can chat those in or type them into the Q&A panel. We will monitor those. And perhaps maybe at the end, we can open up the microphone for live questions as well. Uh, but as we usually do, we show our kind of upcoming events, and we have a couple of tech talks on the schedule. We have more past the August date here. We have pretty much all of them for the third quarter identified. But our next one, Tech Talk, will be Plant PX System Estimator, which is a good session on how to use the estimator and integrated architecture builder. And then we'll look at lockout tagout, which is always a great safety topic. So it'll be a good discussion there. And for those of you who were expecting the redundancy best practices user group back in June, we called an audible last minute, and we brought in Clarity to kind of also do a cybersecurity topic. We are going to do that redundancy best practices next week in the July user group. So apologize for that last minute change, but we thought it was important to bring the cybersecurity topic in to June with all the events that have been happening recently, which also leads us to why we're doing today's presentation with Luis. So one last thing, we are recording this session as it was announced a moment ago. And this, of course, recorded session will be available on our YouTube channel, the Reynolds Company YouTube channel. You can always watch and refer to later. And also, we'll mention that there is a post session survey that we will do today. So if you do want to get more information on today's topic and would like to get, to talk to someone in more detail or just get more information, as you exit the seminar today, there'll be a brief survey just to kind of enter your name and perhaps what type of information you'd like to get. And we will be more than happy to contact you and discuss that with you. With that, I will let Luis take it from here and start our discussion.
Awesome. I appreciate it. Yep, for everybody that joins, thank you for joining us. So my name is Luis. I am with Rockwell Automation, been with them for about 10 years. Hopefully some of you have actually heard me present in the past, worked with Reynolds for quite a few years now. We are going to be talking about industrial cybersecurity. What I'm hoping to do is kind of do a high-level overview of some of the cybersecurity risks, provide some examples, what to do before, after, and during a cyber event, and then just also provide some information. So you guys are welcome to put in questions as we go through. Let's get started. This is your traditional why are we here slide. So we've obviously all heard of quite a few cybersecurity attacks in the news. Over the last 2 years, we have seen a massive rise in 2020 and even 2021 regarding critical infrastructure attacks. Specifically, now we're starting to see more and more attacks that are focused on our industrial control systems, whether that would be from X or Y vendor. So all of us have to kind of take a look at what we're doing as a whole, not only just the control system, but also the policies, procedures that we're looking at. Some of these that are on the slide are just a few quick kind of headlines that we've seen in the industrial security space. A few that you guys may have seen. Since 2017, we've dealt with one that was called NotPetya. That was a destructive malware that actually attacked Windows-based system. It was called not Petya because Petya was more of a encryption attack, where not Petya actually was destructive. It would remove the data that was currently on those systems. Recently, we heard of Oldsmar. That was a wastewater in Florida. That was going after weak passwords on a remote access software piece that was part of the industrial SCADA system, providing the ability of going in and changing a variable on the SCADA system. Thankfully, that was caught, but just looking at it, that wasn't even a difficult intrusion. That was being able to take advantage of something as simple as admin on a remote access software. Another recent one, Colonial Pipeline, that was a ransomware attack that was specific against the IT side of the business, but as a secondary result in something that they had to do as out of caution, they did shut down operation and caused a huge disruption that everybody was aware of. Run on gas was a big kind of secondary effect that happened from there. And the other one that you may or may not have heard about is Triton. So Triton's not one that I have here on the list, but it was actually malware that was directed and modified in-memory firmware of an SIS system, so a safety instrumented system. You can imagine the kind of impact that that might have. So that would potentially allow read-write access directly into the safety instrumented system. So when we start looking at these attacks, it is not only now on the IT side, but it is definitely on what we would consider the OT or the operational technology, the process control systems, inclusive of the SIS systems. So I wanted to start really by looking at our overall industrial cybersecurity risk and understanding the risk, understanding what makes up a threat, a vulnerability, and potentially an impact. You can see on the slide, so security risk, when we start looking at that, that's the likelihood of a threat against a specific vulnerability, which results in an adverse consequence or impact. So as part of the presentation, I plan to provide a couple of examples for each one, and also some of the potential mitigations or countermeasures that we might see in conversation as we're having discussions, both from, like I said, Rockwell as a solution consultant, or even your vendor and like the network specialist at TRC. So some of these threats can be considered external. So these are your traditional outside threats. We start talking about cyber criminals, hacktivists, even nation state actors. When we're starting to talk about the external, those could also come from the local process control network. So think of direct connections or potentially even infected machines, infected laptops, infected USB that are coming from an outside source. And then we also need to be aware of insider threats. These potentially could be accidental changes, disgruntled employees, having access inside. So not all threats, as we have this discussion, will be external. A lot of the times people think that just by creating an air gap, they're providing their kind of sense of security, when realistically some of these threats may be in the plant floor, the facility, and just tying in directly from their laptop. Some of these threats can be malicious, but as I mentioned, they could also be accidental. So what we end up doing is we look at it, do a high-level risk assessment that allows us to see the overall risk and see what we would do as far as approaching the mitigation and countermeasures, actually putting a plan together. One way to measure your risk is what's called qualitative, and that's looking at the likelihood and how large the impact is for the likelihood of that event. Another easy way, or kind of more common way of looking at things, especially from a cybersecurity risk perspective, is quantitative risk. This is usually looking at your dollars and cents, financial impacts for different investments, your cybersecurity budget, and specifically how how much against downtime. So when we look at an event, will it cost you more in the long run for inaction versus spending a little bit of money or spending some hours when it comes to creating these countermeasures, or what we'll see is maybe potentially just doing an upgrade to a patch or a firmware. So let's go ahead and take a look at some of these examples. And like I said, feel free to ask questions in the chat. If not, we'll leave some time near the end. The first one here is threat. So we look at this as a malicious act that seeks to damage, steal, or disrupt data. So typically data is the big piece that we're looking at. So this could be information that's coming from the SCADA system, the DCS, or potentially even the information and the variables that are coming from the control systems themselves, control logics, compact logics. As mentioned, these could be both external and insider threat actors that we have to deal with. So the first example that I'm showing here, and just so you guys are aware, on the left-hand side are just a couple extra examples of what could mitigate or what could be part of a threat. We're going to focus on two here. So the first one is malware. So you might have heard malware, ransomware is another very similar. So malware here is software that's designed to exploit a system. So a majority of these will generally affect Windows servers, workstations, operator stations, but they're not limited to that. As we see, this is, again, it's going to be external. Potentially an infected laptop, an infected USB would carry this malware, and it would then propagate through the rest of the system, especially if it's networked. It doesn't have to come from a cloud or enterprise connection or quote unquote the internet. You can simply just walk in with a contractor that has an infected laptop, connect into your control system, and that could find its way through your SCADA. So some of the countermeasures that we typically start looking at, protection against the industrial control infrastructure, so the network, the servers that are there. The first one there is just installation of antivirus software. This is looking at protection against known threats. So there's a huge database. If we know that a malware exists, typically these antivirus software, especially if they're kept up to date, will be able to protect against that. They'll see kind of the same signature that's assigned to that software and protect it, block it, keep it from infecting or propagating through the system. If we're looking to protect against unknown threats, the other option here is to look at installation of endpoint protection or endpoint security. This typically goes a little further. It's looking at your entire system, creating a baseline so that you're block the use of applications that are unsafe or unauthorized. So again, typically we'll see that as an option. When we start talking about security, a lot of the times we talk about defense in depth, the security onion. You're not going to solve all problems by installing one piece of software or doing one piece as simple as adding antivirus, but it's one item to add as an overall protection scheme. So it might be a combination of multiple of these. It really just depends on your risk. Another potential option here, if we're talking about malware, is having dedicated engineering stations. Some of the customers that I deal with have dedicated engineering stations that they use for all of their development, whether it's for internal engineering or external. So third-party contractors that come in would be forced to use a dedicated engineering station, which removes external or unknown assets. So I&E laptops, computers, servers, any outside source that you haven't been able to validate, it removes that by forcing those external contractors to use a dedicated system that you provide. And as such, one of the things that we'll talk about is maybe using something like Asset Center or FactoryTalk Security to make sure that they have guest and temporary access into the system and you set their access rights. So this is very similar to looking at blocking USB access, banning external USB drives, removing the potential of having that external threat come in from unknown sources. The second example that we'll look at is a pretty large cybersecurity risk. And as I mentioned, not all of this is always malicious. So in this case, human error can be introduced by lack of knowledge or realistically simply by accident. So we'd be looking at either insider threat. This could be one of your employees. This could be an external contractor. We've kind of all been there, done something by accident, connected into the wrong network controller. Specifically, if everything is networked and you're tying in directly to the panel in front of you, if you don't know the correct IP address and you're connecting in via Ethernet, there's nothing necessarily preventing you, if there was no countermeasures done, from connecting into another controller, another VFD by accident. So we'll talk about some of the countermeasures there. Also, potentially changing the wrong set point. You're on the wrong graphic screen on your SCADA system, on your panel view, and you go in and you change the set point, realize that that set point change was on the wrong page, on the wrong system, the wrong area. So when we start looking at countermeasures for this, especially in terms of removing potential human error, we start looking at defining security zones. Segmentation that's not only on system function, but also by role. So we start looking at operators, maintenance personnel, administrators. A good example of this, when we start talking about separation of duties, maybe your basic process control versus the safety instrumented system. So the BPCS versus the SIS. Typically, those are two different maintenance personnel groups. So different groups, different folks that have to deal with it. You can have different assignments so that one does not have access to another. And obviously that depends on your policies, but that is a pretty easy kind of example to look at. Another way of looking at this is also implementation of an MOC process, management of change, something that's defined and requires an approval process for all controller changes. Along with that is the ability of being able to track any changes that are happening to the system as part of an audit log, knowing when someone is connecting into the control system, seeing what changes are happening in real time. Is somebody changing a set point? From what location are they changing that set point? And not only from just knowing that it happened, but also knowing what operator, what maintenance person, and what terminal are they using. So an example here is we typically look at Factory Talk Asset Center on the Rockwell side. It allows backup of all the controller configuration files, but it also provides an audit log for all the system changes, including the HMI, the panel views, the controllers through Studio 5000. So we would be looking at all the controller code changes, as I mentioned, set point changes on the HMI. You can even track when somebody is logging in and out of the individual clients. So if they forgot their password, you'll see an audit log telling you that they got the password incorrect. So these are just a few examples when we start talking about threats. If we look at vulnerabilities, so again, when we start talking about the risk here, the likelihood, we're looking at both the threat actor and then tied in with what vulnerability. A vulnerability is looking at a weakness in a network, an operating system, and most importantly, the process. So the policies and procedures that are tied to the process control network. This isn't always just focused on hardware and software. Again, we're looking at the policies, the procedures, kind of the rules in place for the overall system. One of the biggest uphill challenges in industrial security is actually following industrial security standards in the process control infrastructure. So one big example, and the first one that we're going to be talking about, is weak passwords. I think at this point, we all know someone. Occasionally, we were that someone. We've seen passwords that are written on a Post-it note tied to the monitors. We've all kind of dealt with the operator username and password, or operator 1, operator 2, operator 3. For anyone that I designed an HMI back when I was a system integrator, I extremely apologize for the fact that there's probably an ftadmin username and password, which was kind of my calling for a backdoor and make sure I was able to configure a system. So for anybody that might be on the call, I apologize. But when we start looking at that, those weak passwords, we're dealing with that in our personal life, from a not necessarily even an IT, but looking at your finance records, your access, and all of that is now requiring more complex passwords. We need to also do the same thing when it comes to the process control system. So when we look at countermeasures for this, implementation of industry standard password management, there's a lot of documentation around that, specifically around Rockwell. So one quick example is removing all user access when we start talking about FactoryTalk View on the HMI side, the SCADA side, the DCS, is making sure that there's no global automatic access into the system. It all should be dedicated to a user or a role. Also, the use of a dedicated domain controller, something that's part of the control system environment that provides you the ability to manage group access, what we would consider a security authority, something that's providing access that we can use and leverage. Those policies would be set on the roles like operator, maintenance, admin, and you can have those roles be part of the domain controller and then use FactoryTalk security or another mechanism of being able to kind of pass that along to the HMI. So we set the username passwords as part of the domain controller, and you can manage that so that the policies that manage your traditional username and password also help you manage access to who has access to the controllers, who has access to the FactoryTalk products. So like think of FactoryTalk View, FactoryTalk Asset Center, Studio 5000. So you can easily go in there and say, if you're an operator, you have no business uploading, downloading to a controller. You can limit that through that access, but you can do it in a way where you're tying it specifically to that individual and providing them access based on their role, not necessarily just by the name. So everybody in the operator group would have those same kind of role requirements that are tied in on who has access to what. And you can go as granular as going into the individual person. But what that allows you to do is, when we were talking about the threats, we talked about that audit log. If everyone has their own username and password that's dedicated, those roles, those individual personnel are now part of your audit log. So you can see when somebody's going and modifying a system, and you can track those events down to the individual client, the individual user, and the time and date of when something happens. Another good example, or something that we promote, is the use of two-factor authentication. Some of the time, this is looked at not only the username and password, but this could be location-based, making sure that you're tied to a specific area. This could be looking at making sure that you have something that you carry with you in case, for any reason, the username and password is compromised. So on the Rockwell side, one of the big things that we usually recommend is the use of Thin Manager. So when we start looking at Thin Manager, that allows us to do two-factor authentication, both from the user defined set that I was talking about with the domain controller, but then having something like an RFID badge scan. And these could be the same RFID badges that you currently use to get in and out of different rooms. You can tie this to specific terminals and specific locations, as I mentioned. So all of that is allowed. The other huge benefit to a role base in this type of system is you can also present information based off the role. so that not every person that ties into a terminal always gets the same information. You can make it dedicated based off that role, whether they're an operator, a maintenance person, or maybe even an administrator. The second example is a little bit easier. We start talking about physical access. Um, as I mentioned, not all threats are external. This could be somebody simply walking up to your panel, attempting to either unplug cables, plug in cables. They're going to look to exploit the system potentially at the device level, as I mentioned. The first countermeasure, the first mitigation that I'll talk about is probably the most unpopular of the group, the key switch position. In control logics, in compact logics, what we traditionally have as a recommendation is we have a simple key on there for run, program, and essentially stop. So when we start looking at the run mode and program mode, typically almost, I'd say about 90% of us all have the system in remote mode so that we can go in with Studio 5000, we can make these changes. One very valid option is to set the key switch to run, which would not allow any external or remote access in through Studio 5000. I completely agree that this solution doesn't work for everyone. There are multiple mitigating circumstances where that is not unavailable, especially if you're on a remote site, you don't have the personnel or distance is an issue. But when we start considering the complete defense and depth strategy, just be aware that that is an option. What we typically also look at is the use of locks. Make it harder to open the cabinet, put a lock on the cabinet. Look at locks that might go on the actual network equipment. So locking out USB ports, locking out spare Ethernet ports, or potentially even having lock-in cable so you can't easily remove an Ethernet cable. And in most cases, all of these are color-coded to make it easier to understand what that connections should be. So those are pretty easy to find. I've seen those used quite a bit. The last one here is something that most of you may or may not be aware of. In control logics, there's a security feature called trusted slot. This provides you the ability of restricting essentially the communication port to a specific slot in the chassis. So that could be a dedicated, let's say slot 2 is the only connection that you're allowed to make a remote connection with Studio 5000. All other slots, if you tried to connect in with, let's say that rogue Ethernet adapter that you plug into the back of the chassis, it still wouldn't allow you access to Studio 5000. You would make that call at the beginning when you set up the controller and could easily be used to, let's say, disable the USB access port as an option. This is built into Studio 5000. It's part of FactoryTalk Security. It's available on virtually any control logics family. It's just one of those things where traditionally we don't see that turned on very often, but it is definitely an option. We can always provide more information to you guys if needed. The last one, when we were talking about cybersecurity risk, is impact, so a consequence of the security event. So we looked at threats, we looked at the vulnerabilities. The impact side of it, cyber attacks can't always be viewed as financial. Sometimes they're data-driven, but what we've seen recently, especially we've had some major impacts when it comes to critical infrastructure. And as I mentioned with Colonial as an example, there's quite a few secondary consequences that happen that aren't necessarily tied specifically to the cybersecurity event, but is a consequence that we have to deal with. So the main example that we're going to look at here is kind of the easier one that we would tie in is loss of production or downtime. One of the countermeasures is, so if we look at maybe in a typical plant PX or process control system, we focus on descriptive analytics. Those are typically alarm events, historical and real-time trending, maybe even production events. But from an industrial security point of view, we should look and expect the same type of information when we look at understanding the network, understanding our kind of posture when it comes to cybersecurity as a whole. So some of the things that I'm going to mention here is having a network management system where you understand infrastructure changes, what protocols are being used from an industrial side, Ethernet IP, Modbus, TCP/IP. Is somebody connecting into the network that wasn't connected before? Do you see new equipment or equipment being removed from the system? All of this realistically should be a real-time log that you should be able to access as part of your process control system. Having a real-time threat detection to understand kind of a system-wide baseline, quote unquote, what is considered normal for operation. So this was be something that we should all kind of strive in the OT space, that operational technology, to have the same visibility as we would in a traditional IT system. So having the control system health checks in place, um, Windows operating system patching, vendor level patch validation. So from the Rockwell perspective, we provide a knowledge base that has the Windows updates and kind of verification of what's been tested with Rockwell. We also have the like factory talk system level patches. That's a roll-up patch for all of the software packages, including Studio 5000. All of that is available as part of our website. It's free to kind of look. So those are just a few things that kind of come to mind when we start talking about an overall posture to kind of minimize potential downtime. So what we're looking at here is I put together a kind of a list of common security challenges specifically around industrial security with our traditional systems, again, DCS, SCADA systems, small little compact logic systems. We touched on a few of these as part of the examples that I was setting. Some of these are tied to physical hardware or software that might be installed as part of it. So what you'll see on the left-hand side is I'm kind of separating this out via hardware and software. On the right-hand side, it's policies and procedures. So on the hardware and software side, some of the kind of key ones that we would look at is what's the type of controller that we're using? Are we talking about maybe legacy products similar to like a PLC5, or are we talking about newer controllers in ControlLogix, maybe an L8, the process controller? On the documentation side, do you have a asset inventory of your entire control system? Very similar to like a bill of materials that include not only the firmware, but also the series type. So when I have conversations with customers, a lot of the times I'm trying to understand, is the firmware that you're currently running at 20.05, 33? I know a few of you might be out there in 19, 16, version 11. So that piece of information becomes extremely critical when we start looking at your overall kind of cybersecurity risk. The type of switches that are being used. Are we talking about managed switches versus unmanaged switches? How are those kind of lined up in the system? Are we dealing with, especially on the Rockwell side, device level ring? Do we use parallel redundancy? Or are we just talking about like a single compact logic simplex system? Is redundancy involved? When we look at the policies and the personnel side of it, what I'm looking there is typically, especially as one of the main concerns or the challenges, is lack of training or potentially even lack of policies. As I mentioned, that's probably the biggest uphill climb that I see for industrial security, is just making those changes at the plant floor, at the SCADA system, in the control room environment with these engineers that are tied into it, making sure that they understand the kind of critical nature of cybersecurity as a whole. And then also just understanding your company's approach to security. What are the main priorities? What does budget look like? What are we trying to solve? How critical are these issues? When we start looking at, like I said, the likelihood, so those threats, vulnerabilities, and impact, if you have a very high likelihood, but realistically the impact is very small, those might be things that we put off for later. So with that kind of thought process, and please do not look at the picture and get overwhelmed. This is just kind of there for as an example. What I want to talk about is maybe a couple of pieces that we can look at specifically around hardware and software and the policy and personnel that are quick hitters, small items that we can focus on when we start looking at the overall. So just as an overview, one big thing, again, on the Rockwell automation side, we have plenty of documentation to get you started. So some of the key documents that we would usually touch on, we would look at CPWE. So if you haven't heard that acronym from us before, it's the Converged Plant-Wide Ethernet Design Reference Architectures. We have multiple documents, probably about 30 to 40 different white papers at this point, all covering network, cybersecurity, traversing the IDMZ. So we're looking at network design, security implementation as part of the process control solution, or implementation of your enterprise network. This is a document that's been kind of co-written and includes lab testing information based off of Cisco and Panduit. Again, it's all on our website. You can see it. The link at the bottom will give you access. So that's one option that we'd be able to look at. We also have user manuals and design guidelines to help improve the security of your industrial automation system. This isn't just looking at implementation of something like FactoryTalk security at the controller level, but it's also looking at how we would harden the entire control system. So setting up the domain controller, setting up your firewall rules, looking at the overall posture when it comes to all of the computers, all of the tie-ins, some of the, like I said, some of the procedures, the policies that we would recommend. And then one big document that we released recently as part of Plant PX 5.0 on the DCS side, we came out with what's called the Configuration and Implementation User Manual. That provides a system security checklist as part of the documentation so that we can support one of the industrial security standards. So the IEC 62443, there's a 3-3 component that deals with the infrastructure and the architecture. That checklist would provide what's called an SL1 or a security level 1 kind of requirements list. That goes into detail along with multiple different reference pieces that you can use if you're looking to implement that level of system, or if you just want to get some best practices. So again, if you guys have questions on that specifically, we can answer that or we can have a detailed session. So the graphic on the slide shows an example of what I was talking about for the network security, that CPWE architecture. That's some of the details that we would go in. Again, in most cases in security, we're looking at it being role-based. So the different colors there are just different engineers, different either IT, OT level assets that would be tying into it. Security is not easy, but we shouldn't be considered industrial security when it comes to an all or nothing. Everything is about doing what you can, making small changes, especially small changes that can make a huge impact on your overall cybersecurity risk. So as the Rockwell guy, I will tell you that I'm not going to stop you if you tell me you want to replace everything. But realistically, we have a lot of low-cost options that we can start with. I heard a customer recently say the crawl, walk, run type idea. Cybersecurity is very much part of that. What we can do now could potentially give you time to implement future plans. So what we like to do is perform like high-level risk assessments something that essentially what we're trying to do is fix the worst first. So when we look at this, like I said, from a hardware and software point of view, similar to the chart that I showed you earlier, we would want to upgrade or look at patching your Windows environment. Some of the times this might be as easy as just implementing a brand new virtual image template. As part of PlantPX, we provide virtual templates that have the software pre-installed, and it also comes standard with a specific version of Windows. In most cases, right now, the templates that we have are Windows Server 2016. If you have a Microsoft Windows license, in most cases, they allow you to upgrade to the latest versions. So if I talk to a customer that has Windows XP, they're still supporting Windows 7. That's potentially one of the first things that we look at. And especially if it's a virtual environment, that provides you a lot of options of being able to do that upgrade pretty quickly and pretty easily. The other piece there is just looking at the overall asset inventory list. Do you have systems, legacy systems? Do you have spares? Are you running into issues with potentially older firmware? If we're running Studio 5000 and you're still running on version 20, there's a version 20.05, which is currently the latest iteration that has all of the patches that we've done from a security, from a feature set point of view, without the need of having to change your control system at all. It's just an upgrade to the specific software package of Studio 5000 or Ars Logix 5000. When we look at the policies and personnel side of it, most of the Rockwell products have FactoryTalk security built in. So in this case, I'm talking Compact Logix, Control Logix, even Studio 5000. This allows the use of access control policies like I was talking about earlier. It allows you to kind of define when you go online, upload, downloads, potential changes happen in the system. Typically, enabling FactoryTalk security does not require any new hardware or doesn't require any new licenses. It's just a policy change, implementation kind of guideline that you would use for your existing system. On the newer systems, specifically when we start talking about Control Logix on the L8 platform, the process controllers, the new Ethernet adapter like the EN4TR, this is when we can start looking at leveraging something like SIP security. So that provides you the ability of encrypting at the protocol level, so making a secure connection between your controllers and the SCADA DCS environment. So again, if you guys are interested in that, we can go into a much deeper dive on how we would implement that. But just to start off with, the ability of turning on FactoryTalk security and a lot of the different security features that are already available in Control Logix, in the hardware, in the software, it's just a mechanism of turning them on. Sometimes as easy as checking the box. So one of the things that I kind of want to look at here is as we introduce the kind of attacks, so we talked about, again, the threats, the vulnerabilities. This is looking at it more, so I call it, and this is called the Attack Continuum. So Rockwell leverages NIST CSF. So that's the National Institute of Standards, and it's the cybersecurity framework for critical infrastructure. So what this does is it provides an integration into industry standards like IEC 62443 that we talked about earlier. And it also takes best practices for the critical infrastructure space. This could be leveraged for not only the heavy industries, oil and gas, but also water, wastewater, food and beverage. It applies. So what we're looking at here in this Attack Continuum is from the cybersecurity framework, there's 5 core principles. So you see that identify, protect, detect, respond, and recovery. So before an attack happens, when we're looking at that identify and protect principle, we generally look at this as tools and services to understand your existing control system. It's hard to define your risk, or it's hard to protect something if you don't know what you have. So typically one of the first steps that we start doing is making sure that there's uh, an association, or making sure there's documentation to understand what's part of your control system. We would use systems like FactoryTalk Asset Center with the asset inventory, FactoryTalk Network Manager that also has a capability of being able to see a topology, and also kind of understanding where the control system pieces are, or even going as far as maybe doing an install base evaluation where we send someone out to take a full inventory of your control system, take backups, understand not only the control system, but the network environment, potentially even the software packages that are installed, so that we have a baseline to understand where we should start recommending, whether it's countermeasures, hardware, software, or maybe just policies. Along with that, we also look at potentially patch management services, or even looking at lifecycle and vulnerability assessment management. So one of the key features of Asset Center is now providing you the ability of seeing the lifecycle status of your control system. So take a DLC5, you would definitely see that under red. It would be able to tell you if something's active, active mature, but it also now tells you if there's any vulnerabilities that are tied to our security index that's part of our knowledge base. All of that is being pulled in. There's secure ways of being able to do that, included in a lot of the documentation and white papers that we have. So again, that's typically what we're looking at before an attack happens. During an attack, what you want to be able to do is detect that something is happening. So your most critical piece here is if somebody is making changes to your control system, if there's that quote unquote rogue laptop, you want to be aware of it so that you can plan accordingly. So in the detect phase, a lot of the times what we're doing is looking at having some type of visibility or monitoring capabilities that are part of the control layer, the kind of the OT side of the system. So again, that's looking at audit logs and the alarm and events type information that's coming from the control system, but also setting up a baseline, as I mentioned, so that we understand what's normal in your process. So all of the MAC addresses, all of the computers that are tied to the system, all of the assets that are part of it, is something unknown connects into one of your switches, connects into your controller, you should be aware of that in real time. So typically we're looking at this like anomaly detection for threat detection services. This could be either from Clarity, this can be from Cisco CyberVision, or any number of items. But this is generally what we're looking at the detect phase. And as you can see, that kind of plays into, once you know an attack is happening, you can start to plan and understand what your recovery is going to be. So after the attack, this is that respond and recover. What we look here is making sure that you have a defined incident response plan. The easiest way not to panic is to have a plan in place for when something happens. So you can go through the entire process of having countermeasures. You can go through the entire process of identifying and understanding all of your systems. But if you don't have a plan in place of what happens when something hits the fan, let me put it that way since we're being recorded. When we look at that, you need to understand what happened, what was affected, and follow the plan in place for your recovery. And this is also potentially having a team in place that understands what their roles would be when we're understanding this as part of that incident response plan. So a good example of this is having a comprehensive backup recovery solution. Think of something like FactoryTalk Asset Center. It has the backups of all of your critical assets, the controllers, the HMI, potentially even files that are third party being stored in one centralized database. That could be stored offline or offsite, or just part of the system, so that if something happens, whether it's the controller getting damaged for any reason, we're in Houston, we have hurricanes and things like that all the time. So being able to kind of address that and always have an option to kind of recover from that solution, and having something that not only does backups for your critical control side, but allows you to do comparisons of different versions. So if you needed to revert back to an older version, think of a contractor going out, doing some work, you wanting to have an option to be able to kind of revert back if something that they did causes issues 1-2 days in the future. And also a mechanism of being able to kind of test and implement changes. The worst thing that could happen is you go through the process of backing up all these systems only to realize that the backups that you took aren't valid. So they're also, as part of that incident response plan, should be, as part of the comprehensive piece, methods of being able to kind of test and even implement these changes that you're seeing as part of the system. So again, having that team in place, having these services that are tied in when we look at what we would do before, during, and after. And for everybody that thankfully is still listening to me, I know this is going very fast. Hopefully this is just giving you kind of some high level ideas of what we're talking about here. This slide itself can probably take a couple hours if we start going into it in detail, but hopefully just to give you an idea of what we would think about, what kind of discussions we would have. One of the things that we've seen, especially in the last couple of months, not only because of Colonial, but a couple others, the president signed an executive order on improving the nation's cybersecurity. This was May of this year. This isn't the first executive order, nor do I expect it to be the last in terms of changes on how we approach cybersecurity, not only from the IT side of it, but especially around critical infrastructure, our control assets, more of the process control side. With attacks on the rise, this becomes something where I've had multiple discussions with customers over the last, let's say, 2 to 3 years, from what we would on the Rockwell side call the OT-IT convergence. In general, it's making sure that everyone that's part of the process control network understands what IT is talking about, and making sure that IT understands all of the priorities and the requirements that happen at the process control or the control side. So making sure that we're not shutting anything down, making sure that we understand what the priorities are in both cases. I'm that guy that usually sits in the middle of the room while you have OT and IT. But realistically now it's a fundamental discussion that needs to be addressed in every industry, not really just critical infrastructure. So just know that we will start seeing these. I put a couple of key points that you guys can see, and that's all coming from the top. So after this, I'll open it up to questions if you guys have it. A couple of final takeaways. I won't go through everything on this slide. This is just kind of my somewhat comprehensive list of recommendations when we start having discussions with customers. So we covered and defined industrial security risk. We try to provide, or I try to provide, a couple of examples on common threats, vulnerabilities that we typically face in a control system environment. We have documentation, as I mentioned, so that would help you understand some of your security options, whether you're starting the conversation or whether you're trying to validate the changes that you're currently making in your system. As I mentioned, an example of this is the ability of being able to change the external access of tags inside of a controller. Do you want someone to be able to read write, read only, making it what's called the constant? Those are all available within control logics, compact logics. The trusted slot option that I was talking about for restricting access to the configuration of the controller through Studio 5000, that would be tied in your control logics environment, or potentially even just turning on FactoryTalk security. That could be used not only at the control system side, but the entire software side of all of the FactoryTalk and Studio 5000 environment pieces. And best of all, everything that I just talked about, really require almost no changes when it comes to licensing or hardware. So when we're starting the process, starting the conversation, those are quick hitting items that we can recommend and make modifications to without incurring a huge cost as your overall kind of cybersecurity planning. We also reviewed some of the services and tools that before, after, during that might play. That's all part of that attack continuum. So if you have any questions, if you want to discuss anything that we talked about earlier in any more detail, if you want to sit down, have a review, talk about best practices, or even go into any detail on what I have on the slide. So like I said, it's a list of best practices when we start looking at asset management, visibility, segmentation on the network based on roles, your policies, and also specifically around education, whether that's from the control system environment, more of the cybersecurity standards. When we want to go into a little bit more information regarding 62443, NIST, how we handle that from the Rockwell side of it. And the other piece there is, if you guys are interested, we can also set up a cybersecurity workshop. So reach out to any of the TRC network specialists. I'll have their information on the next slide. And you can always reach out to me directly. I'll have my information on the next slide as well. I'm also available via LinkedIn if you guys just want to follow some of the items that I typically try to put, a couple of documents, a couple of kind of cybersecurity pieces out there as well. Also information regarding our Plant PX DCS system. Thank you for the time. Please let me know if you guys have any questions, if you want to go into any further comments. And Wayne and the rest of the team, thank you for having me on.
Yes, thank you, Luis. That was excellent. Excellent overview and really good advice, and easy things to implement. Shall we, easy in a relative term, but easy ways to get started. Like you said, I like the crawl, walk, run analogy. And of course, here at the Reynolds Company, we can assist you with like Luis was saying, with the security posture, the install-based evaluations, network assessments, and of course Asset Center too. So need any assistance or any information on that, as well as finding all the documentation that Luis had referenced. There's quite a lot of documentation out there, so we're more than happy to help you locate that. And we will give everybody a moment just to type in a question or raise your hand if you want to ask something live. So we'll just keep the line open here for a couple of minutes.
And don't be shy, don't bite.
You did such a great job explaining it. So yep.
That usually means I put people to sleep. That's different.
Hopefully not. It's still early in the day. Everybody should be well rested. All right. Well, we will wait another moment or two. Oh, here we go.
Hey.
You see that?
Yeah, I see it. How do you approach talking to traditional IT people about the needs of OT? That one is interesting because it also depends on, it has a couple different factors. So I'll give you my example of some of the things that we've dealt with. So within Rockwell, I've been here for 10 years, always as part of kind of what we would consider kind of the process control, talking about the architectures. So depending on the roles, the requirements, the discussion points, a lot of the times what we end up doing is just making sure that there's a candid conversation. Communication is always key. When we start looking at traditional IT, a lot of the times what we're also doing is looking at an understanding of who manages what. So in sitting down with IT, a lot of the times it's making sure that they know what the priorities are. They don't understand controllers, at least not all of them do. There are some companies that are actually cross-loading, and their IT department is hiring folks from the control environment, and vice versa. Your process control engineers are hiring IT folks so that they can kind of understand the needs, the maintenance requirements, and the changes that happen from the traditional IT to OT. But it's definitely something where it's just communication is key, making sure that they understand why you're requesting the things that you do. And as the kind of vendor in the room, a lot of the times I could be the middle ground to almost translate the conversation both ways, because of the fact that I come from a controls background as the main person that was doing the programming, the network assessments, or even doing some of the HMI work, to also having that discussions around what the design should be for a overall network that ties into an enterprise. So I'd say it's not going to be an easy conversation, but some of the times the biggest part is just making sure that you have a open channel of communication. I hope that helps with that one. The next question I see from John, what kind of security does a 1783 NAT-R provide? So for anybody that doesn't know, NAT, network address translation, that allows you to essentially create a mask of your IP address. So let's say you have a 10.1 network, but to everyone else, you want to create a public system, and you want that to essentially translate to 192.168.20.1. So anytime you ask for that address, internally it goes and finds the controller that might be the 10 dot. It's the same idea in most cases as maybe creating a virtual LAN, a VLAN. There's not specifically security that's tied to it, but you are in an aspect of blocking the traditional IT network. So you're not allowing scanning of the entire system. Potentially, you might be only allowing to the 3 or 4 devices that you're allowing as part of, quote unquote, the public side of it. So it is a mechanism. It's not the end all be all. But a lot of the times what you're doing there is providing at least some kind of shielding of your overall network size. The NAT-R device in this particular piece also only allows Ethernet IP or SIP communication through it. So that is creating almost as an example, kind of like a mini firewall, so that you're not allowed to pass web page information through a 1783 NAT-R device. So those are a couple of things, but security is not necessarily one of the key features that I would be looking at that NAT-R. Hopefully that makes sense. And if it doesn't, feel free to raise your hand so that Wayne can kind of open up your mic. Edward Davis, thank you. I appreciate it.
All right, well, nothing else, no other questions in at the moment. So we'll pause one more last call for questions. Again, we're all pretty easily approachable afterwards as well. So once again, we appreciate everyone's time for joining us for our technical sessions. And we look forward to seeing you in a future seminar. Thank you, Luis, once again. That was very, very well done.
Thank you, everybody. Appreciate the information. Thanks for joining.